and we talked about starch, talked about cellulose, talked about chitin or chitin, and we stopped on inulin, where we were able to see all these polysaccharides and how they adapted to perform their functions, especially cellulose and starch, the differences they have, and basing on those differences, they perform their given functions. And we were able to describe the structure of a cell wall. Okay, so in other words, you can go and watch our previous video. Okay, you'll be able to appreciate, you'll be able to study and appreciate that. So for today, we are going to proceed with other polysaccharides, okay, that are known, and one of them is peptidoglycan. Right from just peptido, it comes from a peptide, and then glycan comes from a carbohydrate. So it is a carbohydrate with a short peptide chain. Okay, and because you know that proteins, they do form hydrogen bonds, okay, and other bonds within their structures. Okay, so when these when these chains of carbohydrates form small segments, okay, of protein molecules, then these protein molecules, they will be able to overlap these peptide chains. They will be able to overlap with each other and form cross linkages within themselves. The hydrogen bonds, the ionic bonds. How about peptide bonds? Is it possible? Yes, I think when the peptide chains are close to each other, they can condense, okay, to form that peptide bond. And so they will hold these strands, these chains of alpha glucose, of beta glucose molecules together, okay, to form a structure that is going to form a cell wall. And where do you expect to find this peptidoglycan? In bacteria. So whereas plants have a cell wall that is made up of cellulose, whereas fungi have a cell wall that is made up of chitin, bacteria, them too, they do have a cell wall. However, their cell wall is made up of this polysaccharide, peptidoglycan. Not so? Yes. So let's see. Cell wall component in bacteria. We talked about that. And it's the most complex polysaccharide to be discussed. Why? Because you have a peptide chain. It's a combination of both a peptide chain and a carbohydrate. So it becomes a bit complex. Okay? You are combining both proteins and carbohydrates. So it becomes a bit complex. So the long backbone formed by two types of monosaccharides that alternate at each other to form the beta 1,4 glycosidic bond. So this is what we mean. This long chain of a carbohydrate. It has beta glucose molecules. Identical, same. In other words, for formation of structure, it's beta glucose. Why beta glucose? Because it's the one which forms the OH groups and these groups that do alternate. Okay? That do alternate. So that you form cross linkages that alternate, hence forming that parallel structure that is going to form the structure of an organism. If it's plant, it forms a cell wall. So they all have beta glucose molecules. But however, unlike cellulose that doesn't have anything, unlike chitin that has an acetylamide group, for this one, it has a short peptide chain, okay, on this carbon too. And now, in addition, a short chain of amino acids is attached on the two sugar types. So it is added, okay, on this carbon too. Now, when the two parallel strands lie horizontally to each other, like how you can see here, then these two peptide chains, these ones, okay, these ones, they are going to cross each other. They are going to be parallel to each other, crossing each other. So as a result, they will end up forming cross linkages among those short peptide chains. And the cross linkages, obviously, they will alternate. Because you can see if you have on carbon 2, if this one somersaults, it will be this side, like how you can see. And then this one. Now, if this one somersaults, it will be this side. So you end up forming cross linkages which cross each other. And so as a result, those cross linkages will hold the chains of peptidoglycan close together to form a cell wall, which is going to surround this bacteria. Is that really okay? Is that really good? Any queries? Okay. So when molecules of peptidoglycan align, peptide bonds link amino acid chains on the adjacent strands. So they will form the peptide chains, okay, or peptide bonds together with other bonds. Not only the peptide bonds, but together with other bonds, okay, which will link these two chains, these two adjacent chains, parallel to each other, hence forming cell wall. So you can have a look. So this is one strand, one peptidoglycan strand or chain, okay. So you have your beta glucose molecule with that short chain of a peptide. Then the other one, you also have another chain. So when the two chains are parallel, then they form a cross linkage. And the same applies to this. You can have a look. So now there are these cross linkages that will hold these two strands to form a cell wall. That's how you can have a look. And it's as simple as that. Is it okay with everyone? So if there are no questions, then we can proceed to another polysaccharide. Now these ones, the muco polysaccharide, this is your mucus that you always pass out. Okay? When you sneeze, when you swallow, the lining of most cavities, almost the mucus you pass out, it's a muco polysaccharide. So carbohydrates may also contain an amino group. An amino group still on our carbon. Okay? So if you have this amino group replacing the OH, okay, on our carbon number 2, okay, maybe let me try to sketch. This is O, and then this is carbon 1, this is carbon number 2, this is carbon number 3, carbon 4, carbon 5. So if you have there the amino group This is carbon 6, OH. So instead of the OH here, and you have there the amino group, NH2. Okay? Then what is formed is a mucopolysaccharide. It's a mucus. Okay? And it is also a polysaccharide. However, for it, it's not as complex. The chain is not as wide as these other polysaccharides. Okay? Yes, but that's the difference. So polysaccharides that contain that amino group, they are called mucopolysaccharides. And what's the function? Wake up one day and your body can't produce mucus. Oh, it becomes danger. Those are the cases you hear that people have ulcers. You know ulcers. Anybody who has ever suffered from ulcers? Yes. One of the effects is that your body produces HCl, which is too acidic. Too acidic. Okay? And so you must have that layer of mucus to protect, first of all, that acid from damaging the lining of the stomach, and number two, the enzymes, okay, from working on your stomach walls. So now if you wake up one day and you cannot produce the mucus, then it becomes horrific. It becomes horrific. How? That the acid will work on your walls, okay, and the enzymes can also work on the stomach walls. As if that's not enough, the trachea, it must have that mucus. What for? To trap the solid particles, including pathogens, dust, before it reaches the alveoli. And then the ciliated epithelium will bring it up, and you either cough it out or you swallow it. So this mucus is really good. It's really good. These mucopolysaccharides are really good. So mucus is that important. Then other polysaccharides, we have pectins, and these are just polysaccharides that are made out of galactose and galactonic acid residues. So you know the difference between galactose and glucose. It is just that carbon number 4. Okay? Where in galactose the OH is oriented up. So with pectins, the galactose and galactonic acid residues, we are going to see. So it is a major component of the middle lamellae in plants. So you saw when you were forming cell wall. Okay? Yes. So you remember plant cell, which has, let me just sketch, sorry for that. But it has been. So you have a cell wall, and then you have a cell membrane. So now this space between the cell wall and the cell membrane, it is the middle lamellae. Okay? Lamella, if it is one. The middle lamella. So now you have more of pectins in this middle lamella. This middle lamella, okay, as a packing substance, okay, to fill that space. Otherwise, if you don't fill the space, then the cell will kind of provide, it will lack that basic support, okay, for cell to exist on its own. So it provides strength in structures where it is found. So you can have a look. This is our galactose, okay, where the OH is up and it has condensed with another galactose molecule. with another glucose molecule. Now on this carbon, okay, this is probably carbon number 6, okay, this one. We have there an alcohol, it is CH2 in normal glucose level. So now in this, our alcohol is oxidized into a carboxylic acid, okay, which sometimes is replaced by a methyl group. So this is what we refer to as galactonic acid residue, okay. So that is just basically the difference. And now where you have this carboxylic acid, you form strong hydrogen bonds, okay, compared to where you have the OH. So as a result, the galactose is going to bring that strength in that the galactose molecules are strongly held together, okay, that wherever it will be deposited, it will form that, it will bring that strength, that tensile strength, okay, in the structures where it is deposited. Then finally, we have hemicellulose, and this one, remember when we were describing the structure of the cell wall, that we said we have cellulose fibers arranged in bands, and they do alternate differently. Now it doesn't stop at that. You also have fibers that tie, let me use that word, that tie these strands together. So now these hemicellulose, they do that part. They are the materials that do bind these cellulose fibers tightly packed together, okay, to bring about that structure of a cell wall. Now, its structure is complex, and I think it is out of our syllabus. So that's why I didn't bother to bring it. So it provides strength, okay, to the overall cell wall. So you can have a look. So if these are your cellulose strands, okay, then you have the lignin that span through, but you also have these parallel strands. These strands, they are not parallel, but you have these strands of hemicellulose that are interwoven within the overall structure of cellulose to bring about that strength within the cell wall. So basically, that's how we shall say bye-bye to carbohydrates. We have chemical tests for some polysaccharides, and here we shall talk about starch because it is what is within our scope. And starch, we use iodine test, okay? And you just get a food solution that you think it has starch, or even if you don't think it has, but they'll give you a food solution and they say identify. So for starch, we use iodine solution. You can have a glimpse. And so you get the dropper, you get 2 to 3 drops of iodine. You pour the drops on the food solution, on the food sample like this, that is containing starch. And what will be the observation? Obviously, it's easy. A blue-black color if starch is present, and the color of iodine remains if starch is absent. So, any queries? Yeah, so welcome from the group carbohydrates, and we are on group lipids. Okay? So let's see what lipids are. the different functions of lipids, how they are formed, types, and so on and so on. So, according to you, what do you think this is? According to you,
The
what do you?
membrane, plasma.
Uh huh.
The membrane, the cell membrane, I mean.
Okay. Anta, what do you think this is? Okay. So anyway, like how you've said, this is a space feeding model of a plasma membrane. Where the red ones, that's oxygen, these gray ones, that's carbon, white, that's hydrogen, and these pink ones, these pink, yellow, these are phosphorus atoms. So this is a space filling model of a membrane. So this is a protein, you can see protein, and the rest are phospholipids. Okay, so now why phospholipids? Think about why phospholipids, not lipids. And what is that lipid, by the way? Okay, but anyway, by the end of this topic, we shall be able to know all that. So let's proceed. Introduction. They are natural fats and oils, and I hope all of us here, I think we all know fats. We all know oils. Hmm? And we like fats. And can you take beans? Can you eat beans when they are not fried? Or do you even eat beans?
Asante Zito.
You could even say that. So, so the fats, for these ones, they are solids at room temperature, and oils, they are liquids at room temperature. And mind you, the beans which are not fried, they are good for your health. So when we give you such beans, you should really appreciate. It's a lot of energy and too much sacrifice that we give you
I will
such
become
beans.
skinny.
And not skinny.
That's
Not
why you leave school when you are skinny.
no.
They say, why have you gone thin?
No, the reason why you leave school when you are skinny, it's not of it's not because you eat beans and
No, there are no fats anywhere.
no. They are not fats actually which make people grow fat. They are carbohydrates. When we serve you with posho and beans, eh? Posho and beans, this is some good meal. Some good meal with all the 20 amino acids and all the 20 fatty acids. The
Even
essential.
I've never eaten meat from Celsius. It was just
That's a lie. That's a
like for
lie.
real.
Can you stop? You stop what? I'm recording. Stop saying any. I'm recording. Okay, you stop that. So, when we serve you with portion beans, it is some good meal with all the 20 amino acids. You have all the fatty acids. So, there is no need of again adding oils. There is no need of again frying that. No, it's not good.
They are
And
lying.
I'm not. You can imagine how can the teacher lie even?
No, yeah, I've searched
Hey, uh-huh. What have
a
you found out?
combination of a combination of
Of
posho
portion
and beans has only
as
nine
on
amino acids.
9 amino acids.
Nine amino acids, nine only.
You 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 read about the law of complementarity.
Complementarity.
Yeah, complementarity in food and nutrition.
SP.
Complement and then complementarity.
Oh.
So it might have 9, but all the 9 they are essential. Then the rest are non-essential, which can be manufactured in the body. Okay? From carbohydrates, from other non-protein compounds. So you eat your portion beans, you have all the 20 amino acids. Boom! So you can read about this. Okay? You will enjoy that. That's why somebody can.
I'll,
Yeah.
I'll
That's
read and come and prove you wrong again.
no, you cannot. That's why somebody. Anyway, I like that confidence. So that's why somebody can feed on portioned beans day in, day out for 1 year, and somebody does not suffer from malnutrition. Okay? You have the vitamins, some, okay? That is if you are eating whole grain portion. Hmm? Do you know in primary studied posho is considered a fruit, not a seed? Did you study that in primary? Maize, yes. But anyway, obviously you can't feed on portion. So at some point you might have some fruits, but even if you don't take meat, don't take eggs, don't you can survive on portion beans for a year, and you don't suffer from malnutrition. That's why it is good. That's why schools use portion beans. There is no school which serves meat from Monday to Sunday. There is no school which serves nuts, not because they're expensive, but because portion beans, that is the best meal that you can ever find. Okay? So please, if you have that attitude, reduce. Anyway, let's go back. Let's go back to our today's topic. So lipids, they are fats and oils, and like I said, fats, they are solids at room temperature. Can you name them? All those that you use. You use cowboy, you use margarine, prestige, cowboy, I think they are the same. Ghee, now for us, food like ghee. Do I have any colleague here? I think no. So ghee, all those which are solids at room temperature, they are fats. Whereas oils, for them, they are liquids at room temperature. And you can name them. Fortune buto, mukwano, cooking oil, sunseed, oregro, what? Name them, name them, name them. Whatever you use at home. Okay? They are oil, they are liquids at room temperature. So like carbohydrates, fats have carbon, hydrogen, and oxygen only, nothing else. Okay? But we saw that in carbohydrates, the ratio is 1 to 2 to 1. Okay? So if you compare the ratio of hydrogen to oxygen, it is just 2 to 1. But now for fats, oh my god. Yes, they have oxygen, but for a single molecule of a fatty acid, it is just a long hydrocarbon chain. Okay? A long hydrocarbon chain with just a carboxyl end, with a carboxyl group at the end. So the oxygen, it's just 2. You have just 2 oxygen molecules. Okay? So the ratio and the rest, this is just hydrocarbon. Carbon, hydrogen, carbon, carbon. So the ratio of the ratio of hydrogen, okay, to oxygen is high. Okay? In fats than in carbohydrates. So here, for every 2 hydrogens, you have 1 oxygen atom. But here you just see, just 2 oxygen and the rest. So now it's because of that property that we shall see that a given fatty acid or a given lipid of the same mass
Cha,
yields.
I'm out.
You're out.
The phone is shutting down.
Oh, it's okay. It's okay, I'm recording, eh? I'll send it. So for every fatty acid, for a given lipid of a given mass, it yields a lot of energy, okay, than what a carbohydrate of the same mass yields. And so it's because of that property, okay, that the body at times would respire fats. But still there are reasons why body prefers carbohydrates to fats. And you should be in position to compare all that, to discuss all that. Continuation. Natural fats and oils are compounds of glycerol and fatty acids. And what's a glycerol? It is just 3 carbon compound. It won't fit there. It's just it's a 3 carbon compound with OH groups, 3 OH groups, like this, 3 OH groups, and then the rest are hydrogens. So this is a glycerol. The rest are hydrogens. And you know our concept, organic chemistry, carbon has a maximum of 4 bonds. So this is our glycerol. Okay? Now the glycerol, it combines with the fatty acids. Okay? And if you can see, you have 3 reaction groups. And the process is the same, condensation. Okay? So you have 3 OH groups. And the 3 OH groups can condense with a 3 fatty acid. Okay? To lose a water molecule. Okay? And a triglyceride is formed. We are going to see. We are going to see down. Okay? And the bond that is formed, it's an ester bond. You remember in chemistry, esters, they are formed from alcohols and carboxylic acids. So it's an ester bond that is formed. Okay? Unlike in carbohydrates where a glycosidic bond, and unlike in proteins where it's a peptide bond, here it is an ester bond that is formed. And you can see this is our glycerol, okay, and that's how the molecules are arranged within this glycerol. And the formation is by condensation as usual, where you have this pen want to be seen, you have your glycerol, and the glycerol combines with the 3 fatty acids. Now, like I said, the fatty acids, you can represent them as, this is CH3, CH. You remember organic chemistry? I say that you can write your carbon chain as the way you want. So me, I prefer to write it as this. Okay? So the whole of this is a hydrocarbon chain. Okay? Depending on the number of carbon atoms. And finally on carbon 1, okay? On carbon 1, you have what we call a carboxyl group, COH. Okay? Yes. So where this is the omega carbon, is it written as this? This carbon 1 is named as omega carbon. and this carbon 1 is named as the alpha carbon. This, it is the alpha carbon. This is the carbon 1, which is the omega carbon, and this one is the alpha carbon. So now the three of these ones, I think the three of these fatty acids, they might be the same or they might be different, depending. It doesn't cause any harm. Sorry. So the three of these fatty acids, they are the ones that do condense with this glycerol by condensation reaction, where a water molecule is lost. And what is formed? It is a triglyceride. Okay? It is a triglyceride. Where this OH is going to come and take away the H from the alcohol. And the same applies here. And the same applies. Okay? And you lose the three water molecules. Are you seeing? Yes. And what is formed? It is a triglyceride, which is our fat, which is our lipid. Now these triglycerides, they are the ones that will clog together to form a fat that you will see, to form an oil that you will see. Is that really good? Is that really okay? Let me query it for me. Yes, yes, you can ask.
This one, the one with alpha and the omega carbon is
Mm,
those are the fatty acids.
yes. Anything wrong with it?
When you're reacting, you're reacting three fatty acids with the
Y-
glycerol.
yes, three of them. Three of these ones. Okay? With this glycerol, one glycerol, to form a triglyceride. And you think one is here? This is fatty acid. R means an alkyl group. This chain.
The way the way you had written it, I thought it was one. It was confusing me.
No, 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 no.
The way you wrote it in a raw form.
Here,
No, the way you wrote the fatty acids
these
up
ones,
here.
eh? No, they are
The way in that raw form, yeah.
they
I
are
thought it was one. It
they are
was
three of them.
confusing me.
No, it's okay. There are three of them. You have one here, you have another one here, and you have another one here. So they are the ones that will
It's
condense
okay.
with this to form a triglyceride with one glycerol molecule and the three fatty acids. Don't you remember in O level digestion of fats? Hmm? Where they are broken down, they are hydrolyzed by which enzyme? Which enzyme?
Lipase,
Yeah, lipase. To give what are the end products?
glycerol, and fatty
Okay, to
acids.
form a glycerol
Glycerol and fatty acids.
and three fatty acids. You remember that? Were you told? Were you
Yeah.
told that there are three?
No.
Yes. So for each fatty acid, for each lipid molecule, it's a triglyceride. So the enzyme just hydrolyzes this bond by addition of water, and you form the three fatty acids: one, two, three, and a glycerol molecule. Not so?
Yeah.
Yeah. So it is basically as simple as that. So this is our fatty acid, and this is what I wrote in a condensed form, in a simplified form, not condensed form. So this is the methyl group, the alpha carbon, and then the fatty acids, sorry, the hydrocarbon chain, and then the carboxyl group. So where this one varies, this hydrocarbon chain varies. For example, stearic acid, which is used in the formation of soap, for instance, is C35. There are others with C18. I think omega 3 and omega 6. I think they are 318, I think. And we are going to see in our next slide, I think. So this is the space filling model of the fatty acid. So groups of fatty acids, we have essential and non-essential. Like as usual, essential fatty acids, these are the ones that cannot be made in our bodies. Okay? Our bodies cannot make them. And so by all means, you must obtain them in the diet. And they are needed. You must eat a food containing these essential fatty acids. And usually they are plants, not animals. They are plants with these essential amino acids. That's why it's good. It is good and highly recommended to feed on plant foods, to feed on plant fats, in other words, to become a vegetarian than an animal fat. Okay? It is highly recommended. So the essential fatty acids, they cannot be made by our body, and so they must be obtained in the diet. And deficiency results into reproductive deficiency, retarded growth, kidney failure, and so on. E.g., alpha-linoleic acid, or you can call it an omega-3 fatty acid, and linoleic acid, e.g., omega-6 fatty acids. Have you heard of these ones?
Yes,
Where did you hear them?
blue bands.
Blue
In blue band.
Yeah, in blue band. And anyway, I think omega, they just use it, I think, to advertise. But blue band is a hydrogenated fatty acid, a hydrogenated fat. You look at the box. Won't you find there this hydrogenated fat? Isn't it there?
Yeah,
It's there, eh?
prestige is not.
Prestige is not, eh? It
Yes.
doesn't have it. Now, these hydrogenated fats, they get a fatty acid with a double bond somewhere. Okay? And then they add their hydrogen. You remember when we were studying reactions of alkenes? And we talked about hydrogenation of alkenes. You remember
Yes.
that reaction?
Hydrogenation.
Hydrogenation. So
Yes.
they add hydrogen in presence of nickel at 150. And they add
Yes.
hydrogen across this double bond. Okay? To form what we call hydrogenated fats. And these are saturated fatty acids. And this is not good at all. So why are they doing that? Because these unsaturated fatty acids, they do exist as liquids. Okay? They are liquids at room temperature. We are going to see how and why. Okay? And for them, they want to produce margarine. They want to produce blue band, which is a solid. Okay? And so what does that imply? You have to hydrogenate. Convert this one, which is a solid. Okay? And you hydrogenate it into a saturated fatty acid, which can now clog together. Okay? To form a solid that is going to be packed and sold as blue band, as kimbo, as tamu. as cowboy. So now I wonder why they say you have omega-3 and omega-6 fatty acids. Maybe I will continue and read about more. I will continue and find out more. Okay? Yes. Then for non-essential, now these ones, even if you take them in a diet or even if you don't, there is no problem about it. There is no harm about it. Still, your body can manufacture these fatty acids. Okay? Your body can still manufacture these fatty acids. So there is no harm. Okay? Whether you take them or whether you don't. And examples, they are the most common ones. So body can synthesize these fatty acids, and they are synthesized from non-lipid compounds such as carbohydrates, proteins, and so on. So we can see fatty acids.
Teacher, teacher.
So with the fatty acids, they are all occurring lipids have glycerol, that's obvious, and therefore it's the nature of fatty acids that determines the characteristic of a given lipid. So all of them have that glycerol. All of them, they have glycerol, but it is the lipid, it is the fatty acid that brings a difference. Now we have the differences in fatty acids can range from the carbon chain, from the number of carbon atoms, to the nature of the carbon chain, whereby you may have a double bond. Okay, you may have a double bond, and the double bond can be one or it can be more than one, or you lack a double bond and you are just you just have single bond. And so these ones with the double bonds, they are called unsaturated fatty acids. Unsaturated fatty acids. And these fatty acids with a single bond throughout, they are called saturated fatty acids. Fatty acids. Now, the unsaturated fatty acids with one double bond in its carbon skeleton, they are called monosaturated fatty acids. Unsaturated fatty acids. And they usually abbreviate it as MUFAs. They abbreviate it as MUFAs. Now, those ones with more than one double bonds within its carbon skeleton, they are known as polyunsaturated fatty acids, and they are abbreviated as PUFAs. So if you check a given cooking oil, you find there PUFA, and they write like 20%, and then they write MUFAs, and then they write something like 30%, and then they write saturated fatty acids 70%. Now they are telling you that in that oil, the polyunsaturated fatty acids, those fatty acids with more than one double bonds, they are 20%. And those with one double bond, they are 30%. And those which are saturated, they are 70%. And now, this is why you need to be conscious. If you are buying a given cooking oil, a given fat, always mind about this. The higher the percentage of PUFAs, the better that cooking oil is. And the higher the percentage of saturated fatty acids, the worse that cooking oil is. Should I repeat? I've said when you are buying a given cooking oil, always be mindful of the contents. The higher the percentage of puffers, polyunsaturated fatty acids in that cooking oil, the better the cooking oil. But the higher the percentage of saturated fatty acids in that cooking oil, the worse the cooking oil. Why? It is here. The explanation is there. Now, what is the science? What does science say? The science tells us that for these ones that are unsaturated, let me start with those ones. At the point of unsaturation, at the point where you have a double bond, it forms a kink. It forms something like a bend. It will come, and at that point, remember, a double bond restricts rotation. Okay? It doesn't allow free rotation, so it's kind of rigid. So at that point of unsaturation, it will form a kink which will end up bending the fatty acid. The same applies. So this is the fatty acid. So you have another one. It also comes and then forms a kink, bends. Another one, it comes and bends. Another fatty acid. In other words, when they are many, they come and bend. So as a result, these kinks, these bends, they will prevent the fatty acids from clogging. Okay? And so they will have a relatively lower boiling point, which will make this this lipid to exist as an oil, as a lipid at room temperature therefore. But now for these ones that are saturated, because they lack kinks, when they come together, these fatty acids, they will easily clog. They will all be parallel to each other, you can see, which will easily clog. And so this clogging increases the boiling point, okay, of these fats, which therefore will exist as solids at room temperature. That's why when they want to make margarine, they'll get a fatty acid which is good, and then they hydrogenate it to form this nature, which will turn into a solid, so it will solidify. Now the same effect occurs when you consume these fats. As they are being transported, remember they are transported as lipoproteins in blood. So they can easily clog within your blood capillaries, okay? Which will lead to reduction in the diameter, in the lumen of the capillaries, okay? Which will increase pressure, okay? The heart must pump too much for blood to pass through this narrowed diameter. And as if that's not enough, the clogging here, it will fuse with the cells of the capillaries, okay? A condition known as atherosclerosis, which will end up rupturing this blood capillaries. So it's not really good. But now for these ones, and as we'll also talk about that. And now for these ones, because they kink, then there is no way how they can clog. So when they are transported through the capillaries, they will easily be transported throughout from where they have been made from to where they are taken. And so you cannot have such conditions of atherosclerosis and such conditions of clogging to reduce the diameter. Because now imagine if this happens to the coronary artery, the coronary artery, which supplies the heart with oxygen and nutrients. Then you suffer from heart attack. Because you've blocked the coronary artery, the heart won't receive oxygen. Those are the people that you've had. They have died from heart failure. It is simply because of bad eating habits. Then another good thing with these puffers and muffers, the unsaturated fatty acids, is that for them, they form HDL lipoprotein molecules, high density lipoprotein molecules. But for these ones, they form LDL, low density lipoprotein molecules. I told you that these are fats are transported through blood by combining with a protein molecule, a transport protein molecule, and then transported throughout. Now, for these ones, the puffers and muffers, they form a high density lipoprotein molecule. But for saturated fatty acids, they form a low density lipoprotein molecules. And so these ones, they tend, for the LDL, they tend to transport fats away from the liver to the peripheral blood capillaries. Okay? And so when you transport away, remember the liver is the one which degrades these fats. For instance, cholesterol. The liver degrades this cholesterol, okay, into the bile, which is now excreted in feces. But now you are transporting away from fats. So they will easily clog in your capillaries and you suffer from associated diseases. But now the good thing with these ones, with puffers and muffers, they do form HDL, high density lipoprotein molecules. And these HDL, they tend to transport these fats from the peripheral blood capillaries towards the liver. And then the liver will break them down into bile, and then bile will be excreted out. And you are able to regulate even the excess lipids produced. And so in that, your body lives good. Your body lives kawa. So you need these fatty acids. So if you are an animal, if you're a carnivore, it's high time you stopped that and resorted to being a vegetarian. Okay? Yes. So basically, this is what I've been talking about. You can see the saturated fatty acids. You can see how they are clogging. But for these ones, they form kinks. And the kinks prevent them from clogging. You can see? And so that prevents the clogging, you prevent associated diseases and associated conditions. So basically, this is where we are going to stop from. And yeah, we meet in our next lesson.